the first test case. Okay, so for the first test case it is like, okay, looks good. Yes, so here n is equal to 3 and c is also equal to 3. So my candidate pairs are 0 comma 0, 0 comma 1, 0 comma 2, 0 comma 3. Okay, so okay, let me make it 100. So there are some more candidate pairs, but let's check for the candidate pairs which for which x is equal to 0. Okay, so for this I notice that 0 minus 0 is 0 and 0 plus 0 is also 0, and both of these numbers are not in the set 1 comma 2 comma 3. Makes sense? Yes. So okay, yes, they are not there. So this is one of our pairs. So if you focus on this 0 1, 0 2 and 0 3, all of their additions 1 2 and 3 are present in this set. So all these pairs are discarded. Okay, makes sense? Yes. So next one. So for x is equal to 1, 1 comma 1, 1 comma 2, then 1 comma 3. So you see here 1 comma 1 is like their addition is 2 and which is present in the set, so we have to discard this. For these elements their addition 3 is also in the set, so we have to discard that. And the for this pair subtraction y minus x is 2, which is also present in this set, so we have to discard this as well. So we didn't find any meaningful pair starting from 1. Let's start from 2. Okay, so 2 comma 2, 2 comma 3. Yep, because we can't take 2 comma 4 as 4 is not less than or equal to 3. Basically this 3 is the c. It is stated clearly in the question that c is at least as big as y. Okay, so here, yep, so for these pairs 2 comma 2, their addition is 4, their subtraction is 0, both of these elements are not in set, so we have found a candidate pair for our answer. So this is 2 comma 2 is also selected, 0 comma 0 is also selected, and what about 2 comma 3, their subtraction 3 minus 2 1, which is present in the set, so we have to discard this pair as well. Yes, so and pair starting from 3 3 comma 3, and addition is 6 and subtraction is 0, both of them are not present in this set, so we will take this pair as well. So for this particular test case our answer is going to be 3, because these are 1 2 and 3 pairs. Okay, so our answer for this test case is 3. Is it? Yes, indeed it is. So after reading this problem, okay, so this is the most important part of the solution, so hang with me. After reading the problem, I thought of writing the things like this. Okay, so it is actually useful in the most cases that you write data in some structured manner. Okay, so 0 comma 3, some structured manner. Okay, 0 comma 4, 0 comma 5, 0 comma 6, then 1 comma 1. You feel if it is boring, but yeah, stick with me. So 1 4, 1 5, 1 6, 2 2, then 3 3, 4 4, 3 4, 2 5, 3 6, 6 6, 4 5, 2 4, 4 6. Okay, am I predictable? Don't think so. 5 5. Okay, this 66 needs to be little to the downside. Okay, so here 2 6, 3 5 and 2 3. Yeah, so I have written data in some structured manner, I don't know what this manner is, but some structured manner. Okay, now what I notice here is that, so suppose if my set contains 1, if my set contains 1, then I notice that all these elements, all these pairs are like, I cannot take them. Okay, so here I am assuming C is 6. Okay, C is 6, that's why I am going till 6 comma 6. Okay, so if my set has 1, I cannot take these elements, right? And if set contains 2, if set contains 2, I cannot take these elements. Okay, wait, I cannot also take this element. Okay, hang with me. So basically, yep, so this blue part, I cannot take these pairs because addition of 1 comma 1 is 2 and our set contains 2, so we cannot take that. And these elements are like, their subtraction is equal to 2, we cannot take them. Okay, so if my set contains 0, let's say my set contains 0, I may run out of colors maybe. Okay, let's see. So if my set contains 0, then all these guys marked in the yellow color, okay, are out of the our answer, right? So we cannot take them. So for 0 from this matrix, like upper triangular matrix or whatever it is, for 0 I cannot take C plus 1 pairs, right? So these C plus 1 square, I cannot take them. For 1, I notice that I cannot take these 6 pairs, right? Which 6 pairs? These 6 pairs, right? These 6 pairs, I cannot take them. Okay, so for 1, I cannot take C pairs. For 2, I cannot take 1 2 3 4 5 6 C pairs because here C is equal to 6. Okay, what about if our set contains 3? If it contains 3, then we cannot take, okay, let's measure. Okay, color, let it be red. Okay, so for 3, I can notice that I cannot take this 1 comma 2 because of its addition, and all these elements because of their subtraction. I cannot take these elements, right? So count of these is like C minus 1. Okay, for 4 also, you see, for 4, let me change color to violet, purple, whatever it is. I cannot take these elements. Okay, I cannot take these elements. How many they are? C minus 1. Perfect. What about 5? So for 5, maybe orange. For 5, you can notice that you cannot take these elements 2 3 1 4 5 and this one 6. Okay, so there are like C minus 2 elements. Okay, what about for 6? For 6, let me reuse the colors. For 6, you cannot take these guys, right? Because all of their addition is 6. Okay, so again C minus 2. So I'm kind of observing a pattern here. Okay, for 0 only it is C plus 1, and then starting from 1 it is C, then C minus 1, C minus 1, C minus 2, C minus 2. If you calculate it for 7, 8, 9, 10, 11 and 12, 12 is the maximum. See here, 6 plus 6 can give you 12. So it will be like C minus 1, C minus 1, C minus 2, C minus 3, C minus, oh okay, C minus 2, then C minus 3, C minus 3, then C minus 4, C minus 4, and here C minus 5, C minus 5. See here, For 12 there is only one element then that you can reject, right 66, that's it. Okay, 6 comma 6, and here c is equal to 6, so c minus 6, c minus 5, which is 6 minus 5 is 1. So making sense. So that is basically the thing. The values repeat two times. Okay, values are repeating two times. That is the pattern that we have to spot. And one more thing you will be noticing here is that, so see here, so this blue part is for thing that we are not considering for 2, right? So if our set has 2, then we will not take this blue part. Okay, but is it coinciding with some other part? So see here, it is coinciding with this purple part. So basically it is coinciding with this 4 part, right? Anything else? uh, yes, this 6 part, right? So here, right, you, if you notice it, you'll get it. And again, this is the 7 part and this is the 8 part. Okay, so one more thing, notice here, for 8 again you have one element in common, right, for 2. Okay, so even numbers have numbers in common, and they do not intersect with odd numbers. Yes, they do not intersect with odd numbers, and odd numbers or do not intersect with even numbers. Why is such so? Because if y plus x is even, basically if y plus x is even, then your y minus x is also even, right? Is it? It just popped into my mind and thinking on it. Yeah, so here y can be odd and x can be odd, or y can be even and x can be even. So odd minus odd is still even, and even minus even is still even. So this criteria satisfies. If y plus x is even, then y minus x will also be even. That is why. And if y plus x is odd, then y minus x will also be odd. So that is the reason why they both do not intersect. Okay, so that is the thing. And once you notice that, so can I take this thing, maybe, is there any functionality to just take the white colored elements? If you know it, comment it. It will be really helpful for me. So if I, okay, everything is coming down. Okay, anyways, so if this is the thing, okay, can I just take the white elements? Let me try one more time. So anyways, what I am trying to suggest here is that, so your set has 2, then it has 4, then it has 6. So we know that ordering for like the elements that you will exclude are like c plus 1, for 2 it is c, 3 c, 4 c minus 1. Okay, so sorry, for 0 it is c plus 1, 1 is it is c, 2 it is c, 3 it is c minus 1, 4 it is c minus 1, 5 it is c minus 2, 6 it is c minus 2. Okay, but what if I have 2 as well and 4 as well? It is kind of becoming an inclusion exclusion principle. Okay, follow with me. So for 2 I have c elements, right? So I will discard these elements. Okay, let me color them with this color. So I will discard these elements. Okay, I hope it's clear. I will discard all these elements, and when I encounter 4 in my set, so for 4 I have to delete these elements from my count, right? Delete these elements from my count. Are you noticing something? Are you noticing something? Yes, you should, because this is the only number. This is the only number. See, this is the only number that is both common to 2 and 4. It is both common to 2 and 4. Yes, makes sense? Yes, it absolutely does. So for 2, so from our these calculations, for 2 you will discard C elements. For 4 you won't discard C minus 1 elements, you will discard C minus 2 elements, because you have already discarded 1 elements from this set of 2, right? Makes sense? Yes. And what about if you have 6? Then if you have 6, so let me mark the elements that are discarded in this color, in this stripe. Yes, yes. So if you have 6, then see here, so these are the elements that you will discard if you have 6 in the set, right? These are the elements that you will discard basically. So are you pointing the intersection out? Yes, you definitely are. There are two elements that needs to be uh, be like there are two elements that are already excluded. You cannot exclude them twice, right? So for 6 here it is C minus 2, but can we subtract C minus 2? No. I mean, can we remove C minus 2? No, we can only remove C minus 4, right? So that is basically the whole point of the solution. I will count. Basically I will first of all sort the array, sort the given set. Okay, sort the given set. Actually it is sorted anyways, right? Yes, they have given that it is already sorted here. Right here they have given that it is already sorted. So basically it is already sorted, and if it wasn't sorted anyways, so let me remove this, sort the given set, or it is already sorted. And what I'll do is that I will iterate over every element of the set. So if I encounter an odd element, I will keep the counter of odd, how many odd elements I have counted. So basically before 5, if I have encountered one odd element, then I will discard not C minus 2 elements, I will discard C minus 2 minus 1 element. And if there was two odd numbers spotted before 5, then I will discard C minus 2 minus 2 elements. Make sense? Make sense? Yes, it absolutely does. So that is basically the whole point of the solution. So you will keep counter of odd, you will keep counter of even numbers, and basically write the code. I think it is pretty self-explanatory. Solution is self-explanatory. Kinda simple if you realize these points. Like you have to draw this structured diagram and deduce these points, right? Deduce these observations. Okay, so that was a little Hindi word in between. Anyway, so yep. Think solution is complete. I will directly head towards the code to elaborate it further. So yes, I got accepted in one attempt. So okay, why did it format it like this? I have no idea. I coded it on the online CPP compiler and copy pasted here. But anyways, so you will take the input till here, then you will sort. Basically it was not needed, but I did it. I forgot that it was already sorted. Yes, so if it wasn't, anyway, sort it, and you will declare your answer with C plus 1 into C plus 2 by 2. Why that? Because in here in this whole diagram there are C plus 1 into C plus 2 by 2 pairs. Okay, so you will initialize answer with this, and you will check for every element in the set what pairs you have to discard. Okay, so that is basically the thing. So let's go. this is for what is the value for 1 and what is the value for 2, like uh, these things that I have coded it just for the readability of code and make the logic behind code more impressive. Not like impressive, it should impress more meaning, right? My code should impress more meaning, so that's why I have added them. Then count of odd, then count of even, and here like processing every element in that vector or set, whatever it is. If that is odd, then basically this temp is temporary variable to perform operation on this element elem. And yes, difference is like if it is 1, then how much far are you, right? So if element is 5, then how far are you from 1? You are far from 1 by 4, then you will divide it by 2. So here difference divided by 2, so difference would be 2. And see here, from C to this C minus 2, difference between them is 2. So that's how I'm calculating the difference. And this temp 1 is like the number that I have to decrement. Okay, number I have to decrement for 1 minus difference. Yes, so that is basically self-explanatory, I assume. Yes, and negating it from the answer. And why am I adding this? You know the answer, right? So it is inclusion exclusion principle. And I'm doing count of even plus plus. Same thing I'm doing for count of the odd numbers and basically odd numbers in general. And finally outputting the answer. So pretty short and expressive, or whatever it is, short code, carrying much of a logic, pretty short code. But yes, this is basically the whole point of the solution. I hope you enjoyed solving the problem and listening to my solution as well. We are now community of 105 members on our YouTube channel. Thank you for the support you have shown. And yep, thank you. See you again. If you learned something new in this video, consider liking the video. Really consider liking the video. Okay, so uh, based on my behavior, I also noticed that if I found any video useful on YouTube, I will watch it and I leave the video without liking. But when I started my YouTube channel, like I realized that you should like the video if it is really good. Okay, anyways, so consider liking it if you found out this video useful, and consider staying tuned, staying subscribed to our YouTube channel. And yes, thank you again.